I would begin by doing an investigation of the function, and the function ht represents the water level against time, and time t here, that is the time in hours. And we could further simplify this by expanding it to make the problem easier for us. If you do expand it, you get 6 plus 9 e to the power negative 0.003t. And so now I can use calculator, graph it. Now I've already entered the function and just sketch it. And you don't see the graph because the window is not properly set up. So I'm going to use the calculator auto feature. If you're using a TI, you'll be using something called a zoom fit. So okay, X here represents time, so negative has no real meaning. I would try like 10 days times 24 hours, and here water level, I'll make it 0, and maximum water level, I'll try 20 to get a nice feeling about it. Let's sketch this. Okay, very nice. So what's the initial water level? Let's explore this. I can trace this if I want to. And when time is 0, water level is actually here. You can see this is 15. I can trace this as I want to. And when as time tends to really large or tends to infinity, this is like 190 hours or even more, 200 hours. You see the y value, or the height of water, tends to 6. Right, this is very interesting. And also say when it's 48, so 48 hours, you see that water level is 8.13, but the dy dx is something I switch on. It's a feature in this cashier, and see it's approximately negative 0.063, and that is actually the slope of the tangent. I can show you the tangent to that point here. Right, so let's go back here. And what's initial water level? That means when time is 0, all you have to do is calculate this, E0, so you have 15 meters, right? And then find the rate of change in the water level at an instant t. Basically, they ask you to find h prime, and this is your h function, so h prime will be 0 plus 9. Differentiating this, you get negative 0.03 e, and you have negative 0.27. This one. Okay, isn't it nice? Now moving on. Find the rate of change after 2 days. So 2 days, what? 24 times 2 per day, so it's like 48 hours. So h prime, the rate of change, that's the slope of the function. So h prime and t equals 48 is this. Okay, yes, need my calculator here. I've entered this into the calculator. As you calculate this, you find the value is negative 0.06397 roughly, so it's roughly negative 0.0 negative 6397, but we're going to express it correct to 3 significant figures. So 640, okay, 3 SF. So if it's not told explicitly, you just leave your answer correct to 3 significant figures. Of course, don't forget the unit. That will be meter per hour. Right, it shows the water level is always decreasing. Okay, and we have h prime equivalent to negative 0.27 this 0.3t. Now, as this particular expression is always greater than 0 for all value of t, so this expression therefore, okay, so this is going to be positive always, so you times by negative 0.27, so it's going to be negative always, for all value of t. And so h prime, which is actually equivalent to this, is negative for all t. And so that means ht, the function, is always decreasing because its slope is always negative. And we have we saw from our investigation that it is actually going down like this, always, sloping down. And finally, find the limiting height of water. Means that what happens to the height of water when time tends to infinity. So as time tends to infinity, this 0.03t, which actually is this one, tends to 0, 1 divided by a huge value. And so the ht function, which is actually 6 plus 9 this one 0.03t, this going to be like really small, and 9 times 0 is just like 0, so this would function h would tend to 6 meter, and that is the answer to part E. I hope you try other questions, and all the best.